Hi guys, and welcome back in video number 2. Today we're looking at what is meant by a reversible reaction. We're going to explore that in our lesson tomorrow a little bit further. And also, what is a physical and a chemical change, and what's the difference between them? And can they be reversible or irreversible? We'll see. Let's go. Well, here we go. Our learning intention, or dot point for today, is explain what's meant by a reversible reaction and what is the difference between a physical and a chemical change. So the first thing we need to really look at is, what is a reversible reaction? Well, our irreversible reactions are ones that only occur in one direction. So many of the reactions you've looked at so far in chemistry have been irreversible, where we have our reactants and it is going to completion, and that's where the reaction ends. And it's usually limited by that limiting reagent, by one of those reactants that is limited in supply. So an example is a combustion reaction that you've done, so magnesium and oxygen, but also our methane or our ethanol burning in oxygen and producing carbon dioxide and water. Once all the fuel is burnt, the reaction then stops. So then what is a reversible change? Well, don't overthink this. Reversible means it can go back in the other direction. And the way we represent this in chemistry is with a two-way arrow as shown in the slide just here. So the other part of that learning intention for tomorrow's lesson is looking at the difference between a physical change and a chemical change. Now, this is something that you've been doing from year 7, and there's no difference. So a physical change is basically when the form is altered, not the chemical composition, but just the form. And that often happens with our changes of state. So our melting, our boiling, our condensation, and so forth. So this can be reversed. We can have our ice melting and becoming liquid water, or we could have our water boiling and becoming steam. Once we cool that, it condenses and it goes back into liquid water, and we can freeze it again and it becomes ice. So those reactions are reversible. The same with the melted chocolate example as seen again in the slide here. So most of our physical changes are reversible. Dissolving is another example where we can place a solute into a solvent, we can dissolve it, but we can also get that back then through evaporation. Or we could get our water back by condensation. A chemical change is when new substances are formed in a reaction, and some of these are reversible, but others aren't. So in a chemical change, you'll remember from year 7, that's when our atoms are rearranged and new substances are formed. So most of the reactions you've seen to date have been with a single arrow, and that implies a forward direction, and it moves completely in one direction, and when the reactants are used up, the reaction is completed. But some reactions actually can occur in two directions, and they are noted with the reversible reaction sign as shown just below here. And what can happen is the reactants react to form products, but then the products can also react together to go back and form the original reaction. So here we have the forward reaction where nitrogen and hydrogen are combining to give ammonia. And that's seen with a one-directional arrow. And then we can also see the reverse reaction, where ammonia is decomposing to go back and form its original reactants of nitrogen and hydrogen. So today in class, what we're going to do is look at 4 different reactions, and you need to determine whether they're reversible or irreversible based on what you've learned so far. Let's go.